first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone. I am geologist Philip Ong, here with Mr. Dane DuPont from HVERI, the Hawaiian Volcano Education and Resilience Institute. Also with us back today, we have our ASL interpreters, Mahalo, Kiri, and Dano for joining us once again today. We appreciate you guys. And now to our update. This is the Hawaiian Volcano Tracker, Thursday, November 9th, 2023. Kilauea is not erupting still. The earthquakes have slowed down there. There's still some movement happening on a volcano. We'll talk about that here today. Mauna Loa's had a little bit of action. And totally outside of volcanic activity, we've been pretty busy, Dan, this past week. How you doing today, man?
Yeah, thankfully the volcano has given us a little bit of time to breathe on this one, and we're not having to try and do multiple updates going into an eruption or something like that. This past week has been pretty crazy. Past 2 weeks have been pretty crazy. So yeah, we still got a good update for you. Enough action to talk about.
Yeah, for sure. So we'll get to our sharing. Dana will be taking questions on the chat and leading a discussion there. We'll be collecting some for us to discuss along the way as relevant. And all that said, we'll get into it, huh, Dane?
Yeah, sounds good.
Okay, so let's rearrange our screen here. And let's share with you guys. Here's this week's Hawaiian volcano summary. So in Kilauea, earthquakes have slowed down quite a bit. They had been occurring in the central region right in here. So in that area, they've slowed down, but instead we've seen earthquakes continue at either end of this long linear structure, which is part of the Kilauea fault zone, with earthquakes at either end, on the east end here on the Upper East Rift Connector, and all the way on the southwest end on the Southwest Rift Zone itself. Right there. So the earthquakes have essentially moved from where they were in both directions there. These had begun earlier. So this is the map of how they look. As far as the counts, here's the graph of earthquakes over the past month on Kilauea. So the last week is this much right here. You can see how much lower the earthquake counts are than the previous week, and really since the beginning of this activity about a month ago. You see there were several of these pulses of earthquake activity ramping up to this big, large hump here within the last couple of weeks, but that seems to really be tailing off over the last week here. If we look at our GPS stations, like we have been recently, the one that's been of interest has been on Hilinapali, which is about 7 miles from the summit. And the only point here is that the station is still moving in a north-south direction, in an east-west direction especially, showing that the effects of this intrusion are still being felt in the far parts of the volcano. That's part one. Part two is that looking at the tilt at the summit itself, this is the Sand Hill Station, close to that center of uplift for the intrusion. This is the green line that shows the inflation of that intrusion area. And recently, over the past week, it had been deflating, presumably as the magma had been moving down a rift to the southwest. But most importantly, within the last 3 days here, starting on the 6th, we've seen inflation at the summit, both in the intrusion area and at Halemaumau, both those areas. So long story short, the earthquakes have slowed down, and the summit has begun to inflate, even as the effects further from the summit continue to be felt. That's a summary for Kilauea. On Mauna Loa, I'll show you these two plots. This is earthquakes per day over the last month. And here we see these small counts of earthquakes that ramped up here last week. These are largely deeper earthquakes. The counts aren't huge. These are 35 earthquakes in one day for Mauna Loa. It's not a huge amount, but a lot more than the background it had been experiencing. This next plot here is showing depth versus that same month of time. So we can see where these earthquakes occur. And this band of blues and purples in here, these are the deep earthquakes occurring under Mauna Loa. You see they've been going on for some time. They intensified a few weeks ago, 3 weeks ago, were really intense for a couple of weeks there. And just about a week ago is when they seem to come to an end, or at least slow down here. It's a lot slower in the last week in the deep sector, but not before causing a shallow swarm of earthquakes, still below sea level, but within the volcano itself near the surface. So some adjustment happening underground, leading to a shallower adjustment. We know the volcano has been filling with magma, so likely some magma movement within the volcano here in combination with adjustment of the south flank. One last note here in our summary is that Mauna Loa and Kilauea are leaning on another, and the part that Mauna Loa is most influencing on Kilauea is its southwest rift. So there may be some connection, interplay of the volcanoes back and forth there, which we'll dig into a little bit more in our full update. But that's our Hawaiian volcano summary for the week. So that's the long and short of it. Well, lots of details we can talk about there. We'll start off as usual with the largest hazard to people, which is the volcanic gas. We'll turn to the VOG measurement and prediction project from UH Manoa here, as we do most weeks, and look at their VOG forecast dashboard. So here we have the forecast for the next couple of days with the input of current emissions of the volcano, which are fairly low for the volcano, but still significant compared to any industrial operation. So here is Kilauea, and largely the areas that we see effect are colored in this orange and yellow. The typical areas, the southeast flank of Mauna Loa, where you have further reaches here, Pahala and Naalehu and Ocean View are the ones that are most likely affected. as well as in near volcano national park areas, especially when we have weak winds overnight times. That's happened over the last week here as well. Overall, it's pretty good conditions for gas. The gases are usually worse when an eruption actually begins, the very first few days. So just a reminder that between eruptions, like right now, this is the best time, if you live in any of these areas, to try to secure your house, seal the cracks in your windows, all that kind of work. This is the best time to do it, is between eruptions right now. So otherwise, good conditions across the island. And we can see that by turning to our Purple Air Citizen Science Monitoring Network. And it's showing us green dots all across the shape of the island here without showing us the island behind it. But there you go. We'll leave it at that. I won't push it since my computer was not cooperating earlier. I'm just going to kill that right there. So let's turn to the earthquakes now and look at earthquakes over the past week here on Kilauea. So this is a large view of the island. And in fact, I have the earthquakes sorted by largest magnitude here. The largest earthquake we have on this map is in fact all the way out here, 3.9, 25 miles down. This is the settling of the island and surroundings. We call these flexure earthquakes. Technically, I often call them settling earthquakes because I think people can understand that better. Nothing to do with the volcanoes. So you have those happening in the background there. We look into our pattern here. You see some of those in Mauna Kea as well. We see on Mauna Loa, here is that swarm of shallow and deep earthquakes. We'll untangle those a little later on. Down here is our Pahala cluster, still active as usual, with a little curiosity we'll talk about. And Kilauea is really not showing a whole lot here within the last week. The yellows are within the last week. The oranges are within the last couple of days. And if anything had happened in the last 2 hours, it would be red. There's just nothing showing up in the last couple of hours here. So pretty quiet, which is an interesting observation. We've seen quiet both during times of recovery and in times just prior to an eruption at the summit. So still waiting to see how things are adjusting. And we'll keep monitoring that as we move forward through time here. So this map, as I've been saying for the last few weeks, doesn't really give you the distinction in depth. It's giving you the coloration by time. And I do like to turn to this other map that's on the main USGS site. And here I've put it back to capture the last 2 weeks because it's either 2 weeks or 2 days. And it wasn't showing enough. So the full 2 weeks here on Kilauea and Mauna Loa and Pahala. Deep earthquakes are in blues and purples. You can see Pahala, clear cluster over here. Mauna Loa, the blues and purples are over here as well. But you see these oranges and reds, that's the shallow stuff. You see there, all the shallow stuff is smaller. Maybe I can zoom it in without breaking it. Let's give it a shot here. So there is some of Mauna Loa. There's those little events there in colors that are oranges and yellows and reds all around the caldera area. And the blues and purples you see are a little bit broader area than that on Mauna Loa. So we'll come back to Mauna Loa later, but let's turn back to Kilauea now. And here's a map of Kilauea colored by depth. So all the red stuff is the shallowest, orange is slightly deeper, and then blue is the deepest from there. So the reason this is important is because of the Southwest Rift interaction right in here, where you have a mixture of deep Pahala earthquakes in close proximity to these shallow Southwest Rift earthquakes right here. So these are the ones we're really curious about. We want to make sure that we know how far these actually extend. It's not all the way to all this stuff. No, it's just this little cluster right there. And that's an important observation to make from here. Otherwise, everything is as expected across the rest of the volcano. And as I mentioned before, looking at this map from the USGS, which is also colored by depth, where you can see these smaller events showing up here as well. There is that similar cluster, the blues off to the side and the oranges and reds showing the shallow earthquakes in the Southwest Rift there. Yeah, and really curious, and you really can see here this lineation of the Kilauea fault zone, and it's not clear exactly what's going on there, whether magma itself is pushing further over. I mean, it probably is, but how far is the question? Whether it's reached this far is still not convincing to me. I would like to see more information. We don't have all the information USGS has, of course. We only have what's public facing. So it's interesting to note that there could be more to learn about that. Whereas on this side, we've seen this part of the Upper East Rift connector adjust along with a Kauai deck of cards here. All these different faults that are aligned in that direction there. As you have adjustment in this area, that is an area that historically has also activated seismically. So that's less of concern. It could well be that magma has come into this area as well and is trying to reoccupy some of this area. But fundamentally, we know that the East Rift Zone is still closed, pinched off in this area over here. So there's no major concern at this point of short-term magma working its way back through there. Long-term, all these little adjustments are all making it possible for that to happen again in the long term. So someday it will, but we're not seeing that right now. So those are the earthquakes. We'll turn to the USGS updates now, looking at our monitoring segment. And I won't read back through the whole past week. I will just point out some details between what we saw from Tuesday to now. The Tuesday was the 7th, so this is the first day they reported the change in activity that began on the 6th with the summit inflating. So they do note the unrest has diminished over the past week. The decrease in seismicity in association with an intrusive event that began in early October. They are still saying unrest may continue to wax and wane with changes to the input of magma into the area. The current rate of uplift at the summit of Kilauea has also lessened significantly over the last week. However, eruptions are still possible in coming weeks or months. Here on Tuesday, they still say no unusual activity along the East Rift Zone or the Southwest Rift Zone. That's a good summary. If I scroll down through here, I don't really see much else to pick out for you guys. The key thing is they are mentioning diminished significantly over the last week. That's the first part of the last week. Okay, so we'll move on from Tuesday to Wednesday when it changes a little bit. What changes is this. However, a small cluster of earthquakes is being monitored on Kilauea's Southwest Rift Zone right there. And otherwise, they are still saying that increased inflation and earthquakes are expected to precede an eruption. These signals did not appear until 1 to 2 hours before recent eruptions. So definitely hedging their bets there. It does not look like it's going to erupt, but because of this recent pattern of very short buildups, you really can't take it off the table. So still on alert for that to happen. And maybe it will. We'll have to see. On the Rift Zone observations, this has been expanded with the new text about the Southwest Rift. They note that over the past week, several dozen earthquakes have occurred in the middle Southwest Rift Zone. Most events have been smaller than magnitude 2 at depths of 1 to 3 miles below sea level. They say have located near the 1823 vents. We'll look at this briefly, shortly. The rate has decreased over the past days, and that's as much as they say. Nothing else here is really worth highlighting. And then come to today, it's very similar to yesterday's. They're still monitoring the Southwest Rift. Earthquakes are still down. The summit tilt meters are still inflating. Yeah, so that's basically it. The change really coming through yesterday because of the Southwest Rift activity that we pointed out on the earthquakes map. So there is a new map released by the USGS as well. It is this. Now they have, from October 4th until November 5th, the full month between satellite, satellite capture is October 10th to November 2nd. Seismicity is from October 4th to the 5th. But they're actually catching a satellite, which is a background, this rainbow-colored graph, which is called an interferogram. Not that it matters. This is how they measure the ground uplift. And if you haven't seen these before, what's happening is a satellite is flying over the land, imaging the land with radar, and essentially it knows the shape of the land. It then comes back again the following week on the same orbit, takes the same picture with the same technique, and it might notice that the surface of the land is a slightly different shape between the two passes. So they essentially look at the difference between those two passes and produce an image, as you see here, this interferogram. And the way that this works, not to get super technical, is they have a scale here. So the way this map works is there's this rainbow scale. One full cycle of colors corresponds to 1.5 centimeters, about 1/2 inch here. So really what matters is how many stripes of rainbows do you see, for how much is the ground uplifting, and where are those stripes? Okay, so that said, we can see here the outermost stripe that's easily visible. If I look at the yellows, for example, if I look at the middle, there's a yellow ring right around in there. There's another one right in there. Another one goes like that. So you can see where the center is of this uplift, but also you can see how far the furthest effects actually go. This one comes all the way down to here. There's a last yellow line like right here. It's coming all the way around like this a little bit. It's a little bit more obscured there. Not quite as much deformation in this farthest part, but you can see that maybe this furthest reach line is somewhere right in here near this head of the 74 flow, right in there. I point this out because I'm going to flip back to the first satellite image we got, which was from satellites from October 4th to 12th. And in this case, the center of uplift is still over here, as it may be actually closer to the caldera than before. And you can count similar rings of yellow as well. There they are, all coming around. But you maybe can notice the furthest ring, and it's hard to tell. There's the ring there, and maybe another last one over here as well. And so what I'm curious to see is whether we can see this range expanding, right? This lowest most ring here is kind of near the same 74 line. If we come back to the map just released, you see there is that 74 line there. So maybe a similar area of impact, right? What's interesting as well is that if we do see some effects all the way down to here, perhaps that means that there is deformation as far as this most recent cluster of earthquakes down by the Kilauea Hills. You see labeled here, locus of seismicity since October 30th. Before October 30th, it was this region over here. So all this to say, the effects do appear to have spread further to the south last week, resulting in the earthquakes we pointed out first last week as well. And now that seems to have slowed, but perhaps following this, you see the resumption of recharge of the summit here at the top. And we'll look at this in some other ways as well. So maybe it'll help us to look at the monitoring signals. So let's do that here. And on Kilauea, starting with a tilt over the last week. This is the ground tilt measuring the angle of the ground. And over the last week, it started off with fairly gradual, moderate climb. And really on the 6th, this day keeps coming up, we see a steep increase in the tilt. Our scale here is taking us about 8 microradians, which is not a massive amount, but it is significant. Certainly very different than what we saw earlier in the month there. What you can see is correspondingly the earthquake counts here, earthquakes per day. The maximum number here is 40. That's this value. The earthquakes do come back up a little bit as well, but all this is lower counts than we saw previous week. So this is really zoomed in. We'll see that in our next month-long plots here. But to break it out by depth versus time, here's depth. Here's the last week of time. The blue ones are deep Pahala earthquakes. You see there's a little bit of a gap happening right here. And then on the 6th, they do seem to resume as well. interestingly, right? And there are shallow events at the summit still occurring with no strong pattern. And this is a map on which those plots are based that we saw earlier. Looking at the last month, it's a little clearer how the pattern has changed within the last few days. Here is a sixth in the inflation in the volcano that's occurred since then. And now you can see how much steeper it's come up than any time over the past month. We've seen these variations, deflation, inflation events superimposed on this background level of inflation, and that seems to have stepped it up another level here. So we have less earthquakes, we have increasing ground tilt. This is a little bit similar to what we saw preceding the last summit eruptions that followed intrusions to the south as well. So it does leave open a possibility that we'll see this escalate to something shallow at the summit. I personally feel it's a little too soon. It's not quite steep enough, but still we'll put it out there as somewhat fitting a pattern that we saw in the last few eruptions here. Looking at the next tilt station over at Sand Hill, this is the one with two components. The green one points a little bit further southeast towards that intrusion area, South Caldera. The blue one points northeast to Hale Ma'u. We saw very interesting last week, 2 weeks ago, I should say, that even though it began with both Hale Ma'u and Sand Hill inflating, what we saw after that was as the intrusion showed inflation, the Hale Ma'u area showed deflation, like it was moving from the summit away into the southwest rift. Opposite patterns there. Okay, so opposite. And that was really interesting. That changed when this intrusion slowed down right through here at the very end of October after the last earthquake swarm. Then they were both deflating together. And now they're both inflating together again. So that's very interesting to note how the effects really may have migrated away from the summit, and now it's more consistent at the summit as well. There is our same depth versus time, except now we have 1 month of time along the bottom. And you really can see how strong these earthquake swarms are in the shallow regions compared to what we're seeing now is still active, but not nearly as active as before. In comparison, I'll zoom it in so you can see better the relative density, how tightly clustered all these little circles are. The shallow ones, what we care about, Pahala is fairly constant down in the deep sector there. And if anything in Pahala, you might notice that there is that little gap I mentioned right through here that maybe is of interest later on. Earthquake counts over the last month. Here's our little zoomed in section. So we saw the summit inflation correspond to increase in earthquakes. That's that. It's not nearly as big as any of the previous stuff as magma was intruding. Over the last year, it's even more dramatic drop. We're only at about 100 earthquakes this week compared to 1,300 last week. And for the last 5 years, we really are not too far into November, so we really can't compare this very easily. But you can see October was the highest earthquake count per month for the last 5 years. So clearly, very important adjustments happening in the volcano now. Our GPS at the summit, this has been an interesting one as well. We had talked about how this measures from the north to the south of the main caldera, and that distance either expanding or contracting. And that usually is good enough because a magma chamber is in between those points underground. However, when the intrusion occurred last week, it went outside of those. So now we have two stations with an intrusion outside, and they're both moving together or getting pinch closed from that happening outside. That's changed also in the last few days. So that's when we had this essentially flat line wiggling up and down, was when it was caught in between there. Now we see in the last few days the beginning of an increase again. So it's resumed its previous trend back to normal, inflating at the summit at Hale Ma'u. On the rift zone at Pu'o'o, it does look like you might have a slight expansion there happening as well. When you look in detail at the 2-year plots, all the ground is still dropping down there, so it's not getting pushed up and spread apart. It's wiggling and still dropping down. And some of that wiggling is causing parts of the rift zone to wiggle slightly more open, slightly more closed. That's happened in the past here. Here's an example from earlier, how it does this little wiggle. And that's part of this south flank adjustment really pinching off the rift zone. So we can look at that in more detail here. Let's see if I can get this to work. Oh yeah, here we go. There's Google Earth with our GPS stations on it and our tilt stations. So that is our Sand Hill station that we just looked at in a tilt with green and blue lines. Just as a reminder, the green line is pointing this way, the blue line is pointing that way, right? So we're seeing both the summit and the South Caldera area that was feeding this intrusion, both inflating presently, right there. If we look at some of the stations, like start from the north and go south, Uikahuna at the north end of the GPS here. Most curious to me, I'm going straight to this up and down signal over here, this third panel on the bottom, and I'm going to scroll all the way to the right. And what you can see here is that the summit has actually been dropping for the last few weeks here at the summit on the north side. Uikahuna has been dropping in elevation, and maybe here it's finally resuming. We'll have to wait till next week to get a clearer picture because these last data points get cleaned and move a little bit and have some noise. But it does appear like this is also following the trend of bouncing back upwards here as well. Interestingly, and maybe more important, is that it actually dropped at Uikahuna over the last few weeks. And it's not the only place. We come here to Byron's Ledge on the east side between the main caldera and Kilauea Iki. And let's go to its vertical up and down signal. And very similar there as well. And you see it's actually was dropping down. And now the most recent data points look like they're coming back up again. Same caveats as the last graph. So those two stations in the north, right here, both of those were actually dropping down as magma was moving towards the southwest rift. Come to crater rim. Let's look at that up and down signal first. You see it did not actually drop down. It just stopped moving up. It was moving up fast, moving up a little slower, and then maybe slowest of all, maybe not moving up. Once it gets flat, it's not moving up anymore. So this was never at any point dropping. It was closer to the south, but you see it's leveled off there. Because it is in that in-between zone, right at the apex of the seesaw, if you will, we've seen this station during that last eruption move quickly to the north, and then as it swells back, it gets pushed to the south, and then as intrusion migrates further south, it gets pushed back to the north, right? And then coming over here, now it finally looks like it may be turning back to the south again. Not very clear, same caveats, but that piece, that wiggly tooth in between there seems to be wiggling back the other way as well. And it's not just here. This is the crater rim station. And closest at the outlet station on GPS, we can see similar patterns. There's an up signal, slow down, maybe still rising possibly, or maybe it's flattened, hard to tell exactly there. USGS says it's stopped. And the north-south component, you see it was moving to the north, and maybe now finally turning back to the south. So the summit's becoming the more important player for these stations, Halemaumau once again. Okay, so that's the near stations. Further afield, it's not worth getting too far lost in the details. The station that's always been important in this has been the one all the way down here, Hilinapali. This station is getting pushed southeast, right, which is not surprising if the magma is coming all the way to this area of collection. This is the junction of the Kauai fault zone on the southwest rift lineation that way, right? So that seemed to be where it was collecting before then spreading to this cluster and that cluster that's over here as well. This one beginning earlier. So Hilinapali down here is interesting. Let's look at that. And it's still being pushed to the east significantly. It was being pushed to the south really fast. Here's a south signal. And now in the last couple of days, maybe it's adjusting back to the north. It's not quite clear. Maybe it got pushed by magma, but it didn't actually get moved enough where it can push back when the pressure's relieved. Wait and see situation once again, but clearly still adjusting down there. Right? It doesn't look like this signal to the east, for example, has really flattened off very much. Maybe it's beginning to, but it hasn't happened as quickly as the other parts of the volcano. So very interesting. You see you maybe could argue that the up and down signal here was a little flatter, and maybe it's coming up a little bit, but there's so much scattering of data, it's really not as important as these other more convincing signals. So that's a lot of the details of that, right? So I wanted to mention one other thing while we're on Google Earth. Here's our cluster of shallow events. These ones over here are the deep events. On Google Earth, they color by time. And I've put on here the 1823 lava flow as well. So this is the part of that shallow ground crack that's called a Great Crack in this area. And it's interesting because Kilauea has two southwest rift structures. We've mentioned this a little bit before. You have what we call our volcanic southwest rift, which is essentially this shallow crack that runs all the way down this way, becomes the Great Crack down here. This is where we have eruptions from 1823. Mauna Iki was along that area as well. Other eruptions in the 70s, 71, for example. But then you have your seismic southwest rift that runs off in this direction, like that as well. And so this one is deeper, this one is shallower, and somewhere in here you see they seem to intersect and converge once again. And that's this point where these earthquakes are. Right? So certainly you want to be careful of the possibility because of the interaction of this fault with this shallower system. Some of these earthquakes were really quite shallow. Let's see what this one says. Depth 0.7 miles, 1 kilometer, really not deep at all. So yeah, you want to be concerned. But the thing to me is when I hear 1823, I think, okay, it actually was close to an area where it could actually erupt. And that maybe is a little misleading for people because it's still, this distance is still 3 miles between these two areas. So yes, it's getting in a zone. If it were to reach this crack, it could maybe work its way down there pretty quickly. But there's no indication of that yet. It's just more just a reference point. Where is it? There's not a whole lot of reference points out in the desert that people will actually know. This may be one of the closest ones, the 1823 eruption sites. Okay, so that's our monitoring signals here on Google Earth. And we will round out with some visual observations here. And we just, as usual, have these two cameras on a Southwest Rift put up by the USGS. And I saved some clear views from earlier today. That one is the MITD camera. And we have the S2 camera as well here, both showing pretty quiet out there on the Southwest Rift. So that's what's happening mostly underground. What can we see on the surface? I thought I'd take a quick look, and I just turned to one camera. This is a quick, let's keep up with what's going on. This is a S1 camera, daytime views only, looking at Kilauea. And I'll play this on a loop. It's done very, very fast, ever since eruption ended until now. You see a little bit of wiggling uplift of the crater floor at the very beginning of the frame. But more interesting is the growth of the yellow spots. Right? Look at how, especially in here, you can see the amount of sulfur deposited out of the cracks of the lava. There's still lava underneath this crust. It's still degassing. The gas works its way up through cracks on this crust on the crater floor, where it leaks out and then precipitates these sulfur compounds on the surface of the rock. So interesting to note how much that continues to happen. And really, if you go out there and look at it now, compared to what it looked like a month ago, there's a much bigger spot of white and yellow in the middle there. It's really noticeable with the eye. And something I thought we should make sure to cover and highlight on our webcams as well. So that's what it looks like in the daytime. I'll show you the night view as well, because if you look at this at night, there's the full extent of the lava flow in that first day of eruption. Here is that area that ends up getting covered in yellow sulfur. And what you'll see is as this area gets uplifted, it develops a crack down the middle, and this crack starts glowing. So it's going to loop really fast like before. There it goes. There is that crack. And in fact, if you look at the webcams in the evenings nowadays, you can still see this crack glowing. It's still red from this angle on this camera. Some of the other spots have really winked out, no longer bright, but this particular crack seems to be the axis where you still see that heat and glow present. Yeah, 2 months later now. So those are our visual observations. We do have one set of photos released by the USGS. And we'll start off with this here, the annual GPS campaign on Kilauea. We've covered this a little bit before, but they were still doing it in October. And you can see different views of GPS stations across Kilauea. Down by the ocean, another one down by the ocean, up there on the south flank. There's another south flank at the top of the Pali, the hillside. And every one of these, they're centering a GPS over a benchmark that's cemented into the rock so they can occupy the same location every year. They can compare the data year to year to year. So this is their annual campaign. They do it on Kilauea every year. Other volcanoes that are less frequent or less erupt less frequently, they'll also survey less frequently. So that's the Kilauea photographs. However, this is bundled as a Kilauea GPS and Mauna Loa Summit webcams photo update. And a note that HVO staff serviced the cameras yesterday, November 8th, 2023, on Mauna Loa at the rim of Moku'awe'oweo. There's the 2 cameras, 1 and 2. One's a thermal camera, one's a visible camera. They've been largely out of commission since winter and windstorm up there a while ago now, but great to hear that have those back online. Here is an image they took of the view up at Mauna Loa. They say that the new flows are indistinguishable from the old flows on the caldera floor. It all looks the same, just a bunch of barren lava out there. Although we know that all this area, all through here, was all covered in 2022. Well, I could draw a line more accurately, but more or less in there. Here is another interesting aspect of this. It's not just the cameras themselves, but they have to get the data back to the observatory. And so here you see a solar panel, and you see this antenna that's transmitting webcam data back to the observatory. If you look at this, pretty obviously this thing's not pointed at the observatory, it's pointed at Mauna Kea. Why? Because that's one of the main repeater sites for the USGS to get this data back across the island. You need a line of sight. And since this equipment is on the north rim of Mauna Loa caldera, there is no direct view to Kilauea from there. So what they do instead is they bounce the signal off Mauna Kea and then back down to Puna to Kilauea. That's how it works. And if the wind blows cameras and panels, it can easily blow these antennas out of alignment. And that's one of the reasons why you might have data interruptions. Even though data is being collected, it won't be appearing on a website if that's the case. So there is the photo update, and we've really switched into Mauna Loa by this point with those images. So let's jump fully into Mauna Loa here and just look at the webcams to start off. Let's load these up. Current view of the ML cam showing a timestamp of right now, today. Sun is setting up at the caldera. Get some nice colors of the skies. There it is, live camera view. Awesome. Thermal camera, the MT, also a timestamp of pretty recently. Not showing a whole lot of variation because it's just the sun heating up the rocks. So wherever the sun has been shining recently, it's setting over there, it's shining this way, you're going to see more heat. And the scale is important too. MO camera. This one is on the south rim. This one you can see offline since October 16th, 2022, before the last eruption, in fact. So they're still working their way to put these all back online. However, now that we have those other two, we're back to most of them are online. So this is one exception, MO cam. We can keep moving down Mauna Loa. The SP camera is the second one, still offline, October last year. But in the Northeast Rift, at the HV observation tower, this one is right now in the last hour. This is how it looks from Kilauea right now. Looking at the MK2 cam on the Northeast Rift Zone, that's current, reporting live. This is where we're looking at the eruption site last year, although the camera has been panned over to the right. So now we can clearly see the outline of the summit caldera of Mauna Loa there. And there's also the NK cam, which is a little further view, zoomed out. And there it is, also transmitting live as well. Northwest flank, live view of a lot of fog inside of a cloud there. And on the southwest rift, here we are, the M2. This camera transmitted today, but this morning. So maybe they have some follow-up there. This doesn't look too broken. This one goes back to March. The M3, that one is the third one that is really out of commission. And that's really all of them. So you have 3 off and you have maybe 5 or so on. So great job by the USGS getting those back online. It's a constant battle against the elements out here. Remote locations, and you have to take a helicopter to bring all the gear up to repair it. So it's a lot of work, and I know it's involved. I try to share that with you guys so we can all appreciate the USGS for all of that work they do. So cameras are great. What do the signals say about Mauna Loa? Well, the tilt for the last week has been inflating again. Right? These little variations are daily variations that are not of concern. And here is over 1 week time by depth, the plot of earthquakes in Mauna Loa. So really, I'm going to zoom into this very, very far in because it was right after update last week that these shallow Mauna Loa earthquakes began. You see here's 0, that's sea level. Everything below sea level down to 10 kilometers down. So what's that? You're looking at 6 miles-ish or so. That's the range of it. And because time is going this way, you have an interesting progression here where it starts off at the deepest section. And as time goes on, it gets shallower and shallower. That's your typical sequence of magma ascent within a volcano. Right? That's what you expect to see. Quite often it's steeper than that. But so you see it's a progression of magma causing earthquakes down at 10 kilometers, then at 9, then at 8, then at 7, 6, 5, 4, 3, 2. Something like that. And afterwards, quiet. Not only in a shallow, but also in a deep, pretty quiet. So that's interesting. It's notable, this is the first time we've seen this since the eruption last year. We know the volcano is inflating. Magma's coming into it. We know this from the GPS. We'll get to here shortly. In fact, let's scroll down. We'll get to that here. So here's Mauna Loa tilt over the last month. Our last week is here. You see this little adjustment that happened here from the 26th to the 30th. Coincident with the earthquake swarm on Kilauea, the most recent one. And there were other ones similar that are off the map here as well. Okay, so there is our depth versus time again. There's a deep earthquakes. That's shallow swarm right there. If I zoom it in, you can see there's that. It's a little bit steeper looking because we've compressed time. Ascent of magma right there. And afterwards, some adjustments, but nothing really that different than was happening before in the shallow regions, really, right? The deeper regions seem to be a lot slower as well in that regard. So there is earthquake rates. You see it's come down quite a lot over the last year. Here is our little spike compared to 1 year ago, building up to the eruption. And over the last 5 years, here we are, not quite the lowest in the last 5 years anymore, but still below the background we saw in the build up to that eruption for almost all of those 4 years up to last year. Okay, so where are those earthquakes occurring? There's a map for the last month. Blue one's deep, yellow one's shallow. And where's my GPS? There it is. 1 year GPS horizontal, north to south distance. You see it's spreading slowly. It was doing it more quickly. An up and down component here as well was rising up more quickly. And is still rising more slowly here at the very end, almost flat. If we take that over the last 5 years, here's how it looks. The north and south distance, eruption occurs, it spreads apart, lava comes out of the ground, it relaxes, and then recovers afterwards, right, up and down. And the reason we go through this is the expected pattern that we see. Once again, here is the distance similar, measured with lasers, EDM, prior to the 75 eruption, which is this red line here, and the 84 eruption, which is this one right here, prior to and afterwards. So you can see that similar pattern where it really spreads quite apart. And I really want to focus on after the eruption, it recovers for years, sometimes with little wiggles. In this case, it barely ever slowed down before erupting again in 84. After 84, let's see if you can get the right part of the screen here. There is a drop, comes back up, it stabilizes, up, down, up. And then finally, I think it's 4 years or so later, it starts a long trend of downwards from there, where it's clearly not recharging anymore. So that fits what we see now, same kind of pattern as we see, and therefore that's the expected pattern, right? What you don't see, what you hadn't seen until now, was shallow earthquakes accompanying the stretching of the volcano. That's what we have not seen. So we'll now turn to Volcano Watch, because Volcano Watch this week is about Mauna Loa, in fact. What's shaking beneath Mauna Loa is what the USGS wrote about this week. It's hard to believe that nearly 1 year has passed, but a small increase in seismic activity in late October reminds us the volcano remains active. So we've set all of this up. The USGS is able to pull out different GPS stations to make their plots. So they've used 2 different stations and then ones on that graph we just saw to produce a more complete signal here. And there you see it, inflation before the 2022 eruption. There is a stretching, sagging, the recovering and refilling after 2022. You see it begins fairly steep. It's a little shallower. It's a little shallower. Maybe it's a very right end. Maybe it's getting flat there, but these little flat spots don't always last. It can just resume its pattern afterwards. So overall, still refilling. That's normal. But having earthquakes that are shallow is new. It's not alarming yet because it's just a one-time flurry. You expect them to, like we saw over the last 5 years of Mauna Loa, you have to have more flurries, more frequently, closer together in time, with more earthquakes, larger intensity. Oh, that's the progression that we see. So it's just a very, very, very first step towards, hey, maybe it's slightly different now. Maybe in the coming weeks to months, we'll see more changes along that line where we see maybe magma is collecting in the shallow regions enough to start quaking a little bit, right? Remember the last time it quaked for 5 years before erupting. And not to say it's the same as last time. It's a different situation on a volcano today, but just something to keep in mind of the pattern of how things can go. So there is that. And they also show a map. We've seen this before. Right? Same map we just saw. Slightly different times, deep earthquakes. And that is mostly what the article says. What it does say here is what I'll highlight. While recent observations are not alarming, they are certainly thought-provoking. I'll change the words a little bit. Comparing to past eruptions is difficult because the most recent eruption was monitored with better equipment than the previous ones. So they had to compare digital records in 2022 to paper records from 84 and 75 when this occurred last year. So they are looking for signs. The volcano may be indicating a period of elevated unrest, which might be expressed with more shallow earthquakes, but it's not seen yet. And it's more of a thought-provoking piece of information now, because we've seen how long the recharge can take. They mentioned that the first half of the 20th century had, let's see here, what do they say? Only the first half of the 20th century had 12 eruptions, whereas the second half only had 3.
We lost your sound, Phil. Hold on. When you took that drink of water, we lost sound for you.
Okay.
There you go.
Yeah. So the point being, okay, so I'm not sure exactly where that was, but 12 eruptions in the first half of the century and only 3 in the second half. clearly the pattern changed between before and after 1950. And so you have to wonder, could a pattern be changing again? What would it take to go back to this status of many eruptions are possible. Eruptions are possible every few years, as opposed to every few decades. And we don't know. And that's why we're watching closely. So that's the Volcano Watch for this week. And that is most of the update. I do have a little extra research segment if we want to go a little bit more, and this is interesting to me, and we'll do our community and our discussion afterwards. So let me do a little bit of research sharing for you guys here. This is with the story of the hotspot and plate tectonics. And just to share, there are different views of how our hotspot in Hawaii actually is rooted. Right, so here is Hawaii, and it's thought that these mantle plumes come from very deep at the core mantle boundary, CMB, and these very jargony graphics here. Right, so the important thing is the roots from very, very far down. We've talked about this in the past during those kind of updates, which is curious because we see two different chemistries of volcanoes in the state of Hawaii. We have what we call the Loa trend, which is this blue line over here. Most of the volcanoes on the west side fall into this Loa trend. The volcanoes on the Outer Islands, to Oahu Ko'olau, Molokai Lanai, Mahukona offshore of Kohala. You have Hualai and Mauna Loa, Loihi, all lining up in this Loa trend. Whereas the one further east, this red line, that's what we call the Kea trend, after Mauna Kea, includes Kilauea, Mauna Kea, Kohala, Haleakala, West Maui, East Molokai, and it actually seems to disappear past Molokai. So research is still ongoing to make sure that that's really the case, or that this stuff is just offshore somewhere. And further back in time, more questions about what's happening there as well. Without getting too deep into it, I've explained this in other more in-depth updates, but just a summary here. Here is the difference in the chemistry of those two groups of volcanoes. This is looking at lead isotope ratios of the lavas. And you can see that this is the same plot. I just highlighted Loa trend as this side, and Kea trend as this side over here, and Loa trend as this side. So clearly you can see with the chemistry, there's two different populations. And a jump to the punchline, the reason this is believed to be true, proposed in that paper, is that they're tapping different parts of that core mantle boundary. I imagine this is very hard to interpret, so mahalo for that attempt there. So there have been these blobs of what are called large, low velocity provinces. These are areas where earthquake waves move slower. And that's how we see the inside of the Earth, is with earthquake waves. And it's thought that maybe the Loa trend is pulling material from that blob, and Akea is not. And that's really the core of why we have a hotspot at Hawaii. It has to do with this edge right here, and the fact that quite often across the world, hotspots like to be at the edges of these blobs and come up. And without showing that worldwide, that is the case here in Hawaii for us. So what's different and what's new with the research now? This is a article that's been making the rounds for the past week here out of Caltech. It's pointed out by Marin, Mahalo Marin, on Hawaii Tracker. The remains of an ancient planet lie deep within the Earth is the title of this. And this has to do with those blobs down in there. So I'm pretty sure the sound of this is not going to come through, but I'd like to talk over it anyways. What's happening here? So let's, no, that's not going to work. Okay, let me try to just blow it up. There we go. So there's a view of those blobs mapped against the core mantle boundary of the Earth, where they sit underneath the continents. And for a long time, we've wondered how it was actually formed. What we did know was that through plate subduction, this is Chen Yan, the postdoc researcher whose idea this is, an important idea. We've known before that plate tectonics has caused ocean plates to subduct, to dive into the Earth, and move sinking through the Earth all the way to the core. When they get there, they cannot penetrate the core because of a density difference. The core is made of iron and nickel, so there it collects. However, there are some problems with that. And the solution comes from the impact that caused the moon to form. Mars-sized object named Theia impacts the Earth because of the position of the moon, the fact that it's caught in Earth's orbit, its size, its density, all those details. There are some constraints on how that impact had to have happened, right, between that other planet and ours, Proto-Earth and Theia. And the video you saw with the blob looks like magma spinning through space there, that's the newest high-resolution model simulation that's been made. They have fancier computers now. They can do this in much higher resolution and show that that moon can be formed in that manner. Let me see if I can maybe pull that one back, because that is worth looking at right there. Now fast forward it again. So here it is, coming in at that shallow angle. And you see it's spinning out. The moon is going to end up being this blob over here, the far end. And it's just the right distance and angles for it to get caught and all of that. Okay, so that's one that was the first stage of modeling. So these guys, Caltech, they then took that and started looking at, okay, well, how much of the Earth is actually getting molten? Is it possible that it's only a partial effect? And so they've done here a simulation using other techniques here. They've got more of these illustrations here. But the bottom line is that, yes, they do believe that some of this Mars-sized planet named Theia got caught and trapped in the Earth. And its composition must be similar to the moon. The moon is different than the Earth. And it turns in, there's no way to know for sure yet, but the idea is that these blobs down at depth could have been the result of that iron sinking through the mantle. And if you play a simulation of this over 4.5 billion years, you end up with two blobs. Let's pause it. Two blobs. Whoop, nope. Oh, come on. No, I'll just have to play it, I guess. Did not. Okay. Yeah, there it is. One blob, two blobs. Similar to what we see now. They do move around, but that is one possible explanation for why we see those features down in there. This does explain a couple of things. One is that the missing iron from the moon explains the fact that you see nebular gases coming out of certain hotspots on the Earth. So there's gases that seem to predate the creation of the Earth that we couldn't ever explain. Certain ocean island hotspots like have similar rock signatures as the moon, and we couldn't explain that either. And so this does help that come together to some degree. All right, so yeah, there's another one of these simulations. This is that original one that predates this stratified version, but there you go. That's a similar kind of view there. Nice views on NASA. I'll try to speed it up here. The paper is this one in Nature, published November 1st. Moon forming impactor as a source of Earth's basal mantle anomalies. It's a mouthful, of course. This is behind a paywall. The abstract is free. However, there is a lot of, if you scroll down through all this references here, there is a section of supplemental materials. And there are a good amount of graphs in there. Extended data. But then you can come to a section here that has a lot of videos. There are 10 extra videos in here, which are all free and not part of the paywall. So I pulled out the ones that are interesting to share with you guys, just a few here. Okay, so this is one of those simulations. And so they wanted to show this scale down here is entropy. Right? So how, the measure of agitation there, and showing how these two bodies might interact and what's getting disturbed. And the key thing is you have a part in the center that's not getting disturbed as much as the outside. The outside can get like sliced off, but you still have some part of the center of this that can remain solid throughout the impact, whereas some of the previous animations don't make that clear that the whole thing was not liquid. So if you have a solid part in the middle, then it allows a place for all that material to collect and sink to the bottom. Here's a different animation of that impact. Let's rewind at the beginning here. Similar kind of modeling. You see there is some mixing there in the middle a little bit, but you do retain quite a lot of this primordial stuff from the beginning in there. And you do have some mixing, but it occurs in this outer half of the planet there, right? You see all this internal structure the model produces, which is fascinating as well. In case you're curious, this up here, this is accurate. This is the time of simulation, hours. They believe that when this occurred, this is 1 day later. So all this is happening in a matter of hours, all this effect and settling. So there is that. Here's that other video they produced. Let's start it off. Starting conditions, let's set it up here. Starting conditions as they have all these blobs of Theia in the mantle, and they're going to run an animation, and they very quickly all sink because of the density, and then they stay stuck in the bottom. They produce heat plumes for sure. These blue things are the plates subducting down, right? So you can see that they are reaching the core as well and interacting with these blobs, but they're not actually the blobs themselves. The blob causes plumes to come up. You see that hotspot structure is the same, but material from the blobs does not always, maybe a little bit comes up. You're detecting it in the islands, but it's not the main component of what you see. And look, 2 blobs after 4.5 billion years. Right? Interesting how that works. So it's not for sure, but it is consistent. What would make it for sure? They say the Artemis mission coming up, when it lands on the moon, if they can drill into the moon's mantle, collect samples of that rock, and compare it against the samples of what we believe is the component of the blobs coming up through volcanoes, if they match, that's much more convincing. So we just have to wait for a spaceship to land on the moon and drill into the mantle of the moon, get a rock, bring it back, first analyze it. We're waiting for a while, but the idea is going to take off between now and then. And so everything else seems to fit. And that would be probably the confirmation at that point. And so pretty cool stuff, and it relates to Hawaii. And essentially, we're talking about the plume, the hotspot of Hawaii, pulling up part of this other planet into Hawaii, right? And not many places on Earth are doing that. Just adds another dimension to our story here. They're calling it alien planet in some places. I don't know if you can call it an alien planet. It's like there's like a mom planet and a dad planet, right? They're both our planet. They're both us. So I don't know. Certainly, you can call it that, what they call it, the Theia mantle material in there. It's just to show what the research involves as well. They change the density. Like sometimes the density is not enough. So here's a run with lower density. And after a few billion years, those blobs disappear. And so not every case actually produces the results you see today. So they've examined this. Like what actually matters is how hot the mantle was when it's occurred matter. Does the density of the blobs matter? Does the temperature, I mean, all kinds of things. And so what they find is the density matters a lot. And the result that they are highlighting is the density that matches research of other researchers based on both moon results and based on seismic results of the Earth as well. So that was a little detour there. I will leave it at that. There's a lot more I could talk about this, but I don't want to take us too much further here and give us some time to talk about our community events and talk about some questions. So community events are quick. Just to share, the national park still has Mauna Iki and Kau Desert's footprints trail closed because of the earthquakes. That has not come down yet, as of today still. And this is the current loaded page. And we have events happening in the national park in November. The next one coming up on Tuesday, Nani Okahuku, a one-woman living history play, 7 p.m. This is a theatrical performance, but this is based on the diary of Nani Pi'ilani Jones, who was the 11th and second youngest child of the owner of Kahuku Ranch. And she was there during the eruption where lava surrounded their homestead. So this is also an eruption story, and the impact of the eruption on people in Kau back in the 1800s. So that'll be very interesting. The following week, on the 21st, wood turning in Hawaii, a rich Hawaiian tradition. Another interesting cultural exploration there. So we will remind you of that again next week. That's the events in the park. And with that said, Dane, we can say some thank yous, and I'll pass it to you.
All right, sounds good. I just want to take this opportunity to thank everybody that tuned in today. Your support, your likes, shares, follows, subscriptions, all of that fun jazz really does help with the algorithms of each individual platform. We do, if you're on YouTube, we do have a Facebook group. That is the Hawaii Tracker Facebook group. And if you are on Hawaii Tracker, we do have a archive of all of our updates on YouTube, on HVerry. That is our YouTube page. We rely on viewers like you to help get this information out there, the shares and putting, just copying and pasting the stuff that's even here. It really does help try and change the conversation towards a little bit more what's actually happening and less hype and speculation that we might normally see. All right. So thanks everybody for tuning in today. We did have a big super chat come through, a $100 super chat from Tim Hazeltine. And I don't believe there was a message even attached to that. So thank you for that continued support there, Tim.
Mahalo, Tim.
Yeah, thank you. All right. And we only have one question here, if you want to try that one, and then we can get off. We're a little bit over today, but more of our normal almost. Question is from Dennis. Dennis asks, is there a connection between the eastern Pahala deep quakes, which are tightly packed, and the earthquakes at the bottom of the southwest rift zone?
At the bottom of the southwest rift? You mean like in the southwest part, probably? Yeah.
Yeah, probably the south, further southwest.
Yeah, I would say not directly. Let me bring up that map that has both of those on there. Let me see which one it is. It's this one right here. So these blue ones and these red ones, I think, is what we're talking about. Yeah. So I think no. Really, there is a connection, but it's not from there to there, right? It's a connection goes from blue to blue all the way to here, where it rises and then moves back shallower back in that direction again. So like a long snake, it's coming across this way, coming up, and going back down that way. It's like almost like a big U shape, like laying down U shape. Is my interpretation here.
It's good to review it. I mean, it's been a while since we talked about these the Pahala quakes and the relation to the Southwest Rift Zone, and now that we have more action in there, the seismic activity, worth talking about it again.
Yeah, maybe I can pull one if I have a minute here. I can maybe find one image I can throw on here, and hopefully that doesn't freeze me. But let's see here.
We can only hope.
I can find. Yeah, just a second to find these.
We've done many things with Pahala over the years. The earthquakes down there have always been of interest, and they're kind of like a separate category from the other earthquakes that we experience, being earthquakes that are one related directly to volcanic activity. So the earthquakes that we're seeing at Kilauea, and we see those, as Phil was talking about earlier, those flexure earthquakes with the weight of the island sinks down, presses down on the lithosphere, and we just get some earthquakes and settling that happen as a result of that. You found it?
Yeah, there it is.
All right.
So there it is, a cross section. This is earthquakes in the top panel, and the interpretation on the bottom panel there. Right? So this is where they get this interpretation. The depth is big here, 20 kilometers, 40, 60. Right? So the earthquakes we're seeing in Pahala, these are these in the area of these yellow squares. They're distinguishing between tremor and other earthquakes. We're not talking to that level today, just where are the events. So there is a Deep Pahala earthquakes right there. The path is thought to come like this and up into the volcano. And then Southwest Rift back that way. Hopefully you can see that on there. It's not the best color.
It's viewable.
That's basically it, right? Like that, up, and then over, like that. So that's basically it.
Right.
So from the surface, looking down, they are right next to each other, but one's much shallower and one's much deeper, and that's why it matters. With no path, no direct path up between them, the path. This is earthquakes for a long period of time here. You see that they really light up these structures. Moving across there. That deep structure, and then the shallow structure right there. So yeah,
All right.
there you go.
All right. Well, I think that gets us through the questions. Let me just double check. Yeah. So we normal streaming time is on Thursdays at 5 p.m. unless something happens. If we get something building towards an eruption, we might not expect it, but it could happen. We will go live then and try and give you an update if that were the case. Otherwise, we'll be back next week.
Mahalo, Dane. Mahalo, Carrie and Dano. As always, appreciate having you back. Mahalo, all you guys, for tuning in and supporting us, driving great conversation here, helping us build preparedness for the next events here on Hawaii Island. We're hoping to improve preparedness through our education, to improve the response and the recovery to the last eruption, all of that, all wrapped into one here. That's why we do this. So thanks for helping us accomplish that and make our island a safer place. Until next week, unless something pops up sooner, which I do not expect, but as we've seen before, it could happen. Unless that happens, until next week, Thursday, at our regular time, 5 p.m. Hawaiian time. From H. Very, he's Dane DuPont. I am Philip Ong. Aloha, everybody.